of the water system and to put together a perspective of how this all fits into what you're going to see as this proceeds along this evening. Okay, what is the MWRA? What is it and what does it do and how does it affect us? We are a quasi-state authority. We are created by state statute, but have some independence from the rest of state government. It was created back in the mid-1980s to clean up Boston Harbor and to bring the drinking water system up to the federal standards. What are we? We serve 3.1 million customers in 61 communities. On an average day, we'll deliver 200 million gallons of the best drinking water in the country. And in a storm, on the wastewater side, on an average day, we'll transport and treat about 350 million gallons out in Boston Harbor. In a storm, we can handle 1.2 billion gallons of wastewater. We are the wholesalers. We sell to the cities and towns, and they then turn around and put a markup for the retail rate. Our main sources of water are the Quabbin Reservoir, north of Springfield, and the Wachusett Reservoir, north of Worcester. All combined, those reservoirs hold up to 6 years of storage if we ever needed it. And that's a far cry from most of our other peers around the country who on any given summer will be below 50% full. We're lucky if we ever get down below 90%. So we have ample water. It's great water. It's the cleanest water in the country, and we'll talk about that in a little bit. And part of it is the mere size of it and the fact that we own incredible amounts of forest land all around the reservoirs. So the pollutants have no way to get into the water because we own the watersheds. It's a civil engineering marvel that is recognized around the country as one of the great water systems ever built in this country. The Quabbin Reservoir is over 500 feet above sea level. The water travels down through tunnels to the Wachusett and then over to Marlborough, and then it drops down into Route 128, and all of it is done via gravity, and all of it is done, once it passes through and into the tunnel out in Clinton, it doesn't come out of it doesn't come out until it hits Route 128, and so we were safe there. We have the public health. We are a public health agency, an environmental agency, and frankly, a finance agency and a construction agency. But our main focus is being a public health organization who's responsible for delivering clean and ample quantities of water. And one of the things that, well, I'll wait till I get to another slide in this. We've received all kinds of awards, we meet all the federal requirements. Everywhere you turn, people say, hey, I got the best drinking water in the country. And people agree, it really tastes great, and it does. One of the things that people don't think about is the history of the creation of the water systems and the history of the water systems throughout this country. And people understand the need for drinking water, for sanitary things, and all that. That's critically important. But the thing that really drove a lot of the construction of the water systems across the country were massive fires, where the urban areas in and around this country, whether it be Chicago, whether it be New York, whether it be Boston, whether it be Salem, Massachusetts, they didn't have the pressurized water, and they couldn't fight fires. They had bucket brigades and things along those lines, hand pumps, but it wasn't until these fires that folks realized we needed to get pressurized water, and we did. The Cochituate was the first part of that expansion from Boston West and this is a storage tank that was behind the State House, and that was since been eliminated. The Cochituate system was the first system as part of this Drive West. Here is the celebration for the opening of the Cochituate down at Boston Common in the Frog Ponds. Over 100,000 residents came out to celebrate this great feat of engineering feat. The water system from the history of the United States, the history of the Massachusetts water system is basically drive west, drive west, drive west until you get enough water. And this is a picture of the Wachusett Dam. On the top right of this picture, you can see the map that kind of sketches out the travel that the pipes. And this is the Holtman Aqueduct. We have deep rock tunnels, and we have surface arteries that carry the water east. Here's an example. You're going to talk a whole bunch about the boring machines. And here's a piece of a boring machine that was very similar to what you'll see here. And then again, on the bottom, you can see the actual tunnel itself. And I think this one was probably blasted as opposed to a boring machine. We break our system into 5 separate areas, and we strive for redundancy in each one of those. We've been very successful in it, and the system is bold in its investment and its results. We're here today to talk about a tunnel loop that would complete the Metropolitan water system. And it's important to keep in mind, in the 1936 master plan, this tunnel that we're going to talk about tonight was outlined in concept as something that we needed to do as a water system. Now we sit here years later in the planning stages to make it finally happen. And when we finish this, we will be completing the Metropolitan water system that was envisioned over 100 years ago. The area that we're dealing with inside the circle is about 60% of the water demand in the metropolitan area. And I would say without being accused of being an alarmist, if we had a major water main break inside of this circle here, there would be the possibility of deaths, as we'd have so much water and it would crash, and anyway, it would just be ugly. And we also have to maintain what we have. And these are examples of parts of the water system that are just very, very tender. The potential of an accident is serious, and we want to move forward with this tunnel program to get rid of these things and build a new redundant tunnel. Here we go. If we had a major water main break, I'm going to give you a sequential. This is what would go dry first. These areas would dry first as the system drained itself out. Here's phase 2. And it would be ugly. It would be serious. And we had, in the Great Water Main Break of 2010, got a taste of what it's like to have a major water break. And I can assure you, we don't want to live through that again. So anyway, the goal is full redundancy. Kathy is going to talk about it. And anyway, it'll work for you.
Okay, thanks, Fred. So for the rest of tonight's presentation, Paul, Savard, and I are going to walk you through the tunnel program. We're going to spend a bit of time talking about how a deep rock tunnel system is built, the status of the program today, and what's to come in the coming years. This is a large program. It will take many years to complete. So today, as Fred mentioned, we have our existing Metropolitan tunnel system within the Metro Boston area. It's 3 deep hard rock water tunnels. They are about 19 miles in total. When the new tunnels are online, we'll be adding 15 miles of similarly deep hard rock pressure tunnel that will provide full redundancy for these existing tunnels. We'll be adding 11 new shafts to connect the new tunnels to the existing MWRA MWRA system and local water infrastructure. And the connections to the local water infrastructure is important because it provides resiliency not only to our system, but to local water infrastructure as well. And as Fred mentioned, we've been planning this for, well, it's been in the works off and on for roughly 100 years. So what is our program? So the Metropolitan Water Tunnel Program, it's really a once-in-a-generation program that will provide benefits for years and years to come. It involves the construction of 2 separate rock tunnels. These tunnels will be between 200 to 500 feet below ground and constructed entirely in bedrock. We need 13 shafts to build for construction or the water system connections. Both tunnels start in Weston near the intersection of I-90 and 95. The north tunnel will head north into Waltham. It's about 5 miles, just shy of 5 miles. And the south tunnel will head east, southeast, over to Mattapan. And these tunnels are designed to carry a high day demand of 283 million gallons a day. That's a lot of water. So how are we going to build them? The new tunnels will be constructed in 3 segments. We don't build them all at once. And we'll be using tunnel boring machines, or what we call a TBM. And if you're not familiar with a tunnel boring machine, there is a model of one over on a table over there. Take a look. These are really marvels of engineering, and they're very sophisticated. So take a peek at that model. So each segment of tunnel is going to have its own launching shaft, its own receiving shaft, and intermediate connection shafts. The launching shafts are where we launch the TBM, or where the mining starts. The receiving shaft is where we receive the TBM or mining stops. And the intermediate connection shafts allow for those added connections to our system or local infrastructure, and that provide that real redundancy. Paul is now going to walk us through typical tunnel construction sequence, review the work completed to date, and some of the work that is yet to come.
All right, thanks, Kathy. Thanks, everybody, for attending. The next slide, we have an animation, and it covers a number of the topics that Kathy was mentioning about what a launch shaft is, what a receiving shaft is, and how a tunnel sequence works. So I'll just walk you through the animation. But as Kathy mentioned, the construction of these tunnels is quite impressive. The contractors who have to do this in the confined spaces that they work within, and the logistics that they have to follow through are just extremely impressive. So the animation definitely doesn't do it justice. But the first step that the contractor will end up doing is they have to mobilize to the launch shaft and prepare for preparation of constructing this launch shaft. And as we mentioned, the shaft itself will be on the order of 300 or 350 so feet deep, and it's through soil and bedrock. And as they get down towards the bottom of the shaft, the contractor excavates an opening that we call a starter tunnel, and that's where this TBM, tunnel boring machine, is assembled, as you saw over in some of the slides if you looked at the posters. So when the tunnel boring machine gets launched, after all that logistics starts to get worked out, and it's moving about 50 feet a day, so when you have several miles of tunnel, it takes several years of time for the TBM to get there. In the meantime, the contractor mobilizes to the receiving shaft and constructs that similar to the launching shaft. And as the tunnel's going along, you'll hear us talk about intermediate connection shafts. So those will be connections to the water system, but the contractor, we're expecting to construct those using a different technique, which we call raised bore technology. It lets most of the material fall into the shaft so that it's less construction activity at the surface. So that TBM, tunnel boring machine, makes its way to the receiving shaft, and that's when the contractor takes that out of the shaft. And when that work's done, they still have a couple of years left where they have to line the tunnel with concrete. So depending on the soil conditions, it'll be reinforced concrete, steel pipe in some circumstances. The shafts get lined also. So it takes a number of years at about 100 feet a day to line the tunnel, and that's with this concrete. When they get that completed, the contractor's not done. They still have a lot of work to do at the surface. They have to complete the water main connections to the water system. They have to build the structures that are below grade for the valve chambers, secure the facilities, and install the landscaping that will make the sites what they'll be like when they're in operation. And then finally, after all of that, the contractor and the MWRA fill the tunnel up with water, we'll pressure test it, and then we get to disinfect and make sure it's ready to be put into service, and we'll do so. So what the animation is good for is to kind of walk through a lot of those sequences for the tunnel construction. So a lot of people might ask, why did we decide about the water? Deep rock tunnel was the way to go. And so early on, the MWRA, we developed a number of different alternatives to look at different options for providing the redundancy that we so desperately need. So a number of the options we looked at large diameter pipelines. You need some significant pipelines down city streets if you need to provide a similar number of 15 miles of tunnel. So the disruption caused by a similar construction as that would have been extensive. And so it didn't take long to realize that a deep rock tunnel would be the best way to go to minimize community impacts and make sure that we could provide the redundancy that we need for the program that's so important. So that decision led us to preliminary design. And the preliminary design had been going on. We started in 2020, and we just wrapped up in 2024. So the preliminary design was the step where we identified shaft sites. So for the segments of the construction that we need to build, you need to make sure you find a right shaft site, that space that's available for construction, it's got the right size, it's got to be located close to highways so we can get the trucks that need to come in and out and take the material away to be located. So that was an important part of the preliminary design. We developed a tunnel alignment in between these shaft sites, and we were able to develop an updated construction sequence, a schedule, and importantly, the cost estimate to go along with the work. So concurrently, along with the preliminary design, was the MEPA filings. The Massachusetts Environmental Policy Act requires us to do an environmental impact report for a project of this magnitude. There are several steps to it. It started with our environmental notification form back in 2021, and we worked through a series of a draft environmental report, supplemental, and then culminated with our final environmental impact report in February of last year, and we received the Secretary's certificate on that in April of 2024. So in the process of doing the environmental impact report, we're able to take the preliminary design, assess those environmental impacts associated with the work, go back to the drawing board in some cases to try to minimize or mitigate some of the impacts that were being experienced or would be experienced, modify the preliminary design so that we can come up with a more equitable project that's going to minimize construction impacts and operational impacts to the extent that we can. So that's the main purpose of the preliminary design, working concurrently or in conjunction together with the environmental impact, so that to make sure that they're both working together. During the process of the environmental impact, we received a lot of comments at each step along the way from the public and other stakeholders. So we responded to each of those comments and provided detailed responses and incorporated what we could into the environmental or into the preliminary design documents to address mitigations and so forth as the project went forward. All of the documents that we've submitted there, and they're substantial, are located on our website. You can go see them if you'd like to. There's a lot of information there, and it would be definitely helpful for people to understand the work that's involved. One of the spots that people have really seen us doing work in the community so far has been in the geotechnical investigation. And if you looked at the poster board that Brad was talking to earlier tonight, the geology in the area, it's quite complex. There's a lot of different rock types, and for tunneling, you need to understand what you're going to be encountering that 300 or 400 feet down, so you can know that the tunnel is going to be able to be constructed properly. So the geotechnical work, to date, we've completed over 60 of these deep rock borings. We have more to go, but each of those have been collecting the rock core down to the several hundred feet that we've had to go to excavate to. So prior to conducting all of that field work, we made sure we coordinated with each community to notify the abutters and post the notices on our website. For every boring, we got a notice of exactly where the location is. So that field work for those 60 borings so far has gone very well for us. We've got a lot of useful information, and a lot of people might wonder what we do with the rock core when we collect it. So in Needham, we have a facility over on Gould Street that we're able to store all the rock core. And in the picture down at the bottom of this, you can see one rock core box. So that box represents about 15 feet of rock core. But that's, so we got hundreds of those boxes at the moment that are stored in Needham. And our geotechnical engineers and our geologists are going through each one of those to understand what the rock types are down at the depth of the tunnel that we've got. They're able to select certain pieces for testing, find out how abrasive the rock is, how strong the rock is, a lot of different parameters for that. And that's all going to feed into the final design so the contractor will know what kind of tunnel boring machine they need to provide. So that leads us to final design after that preliminary design step. And final design is what has just begun and will extend for about the next 3 to 4 years until we begin procuring tunnel construction. There's still a lot of work for us to do and many details to be fleshed out during the final design, and we'll be talking about more of those things as we go forward tonight. So it is during this phase that we will finalize all aspects of the permanent tunnel system, where the valve vaults will be and the design of those vaults, the specific connections to our water system, the final site configurations, and the system operations, all the steps that we need to do to put the tunnel into service. So we'll also be developing additional requirements for construction methods and sequencing, things like work hours and haul routes and so forth, and make sure that we can incorporate any constraints that we need to into the contract documents so the contractor knows what they need to comply with. So it's going to take a small army of people to bring all that work together for the final design, but including our engineers and geologists and permit people and cost estimators and schedulers and so forth. But our final design engineering team, led by WSP, some members in the audience here, have significant experience in this kind of tunnel work, and they'll be working hand in hand with us at the MWRA to make sure this such a large program moves forward the way it needs to. So although the environmental review process is completed that I mentioned, that's not the last step of the opportunity for input and feedback from the various stakeholders. This is a list of the many permits and approvals that we'll need to get along the project as we're in final design. The permits will become part of the contract documents, and the contractors will need to comply with each. A couple slides more about the construction and what to expect there. So again, each tunnel segment is estimated to take between 4 to 8 years to complete. And we mentioned a little bit about the time it takes to construct a shaft, about a year. That tunnel boring machine that operates for each segment, that's going to take a couple of years. The lining of the tunnel that has to go on after that. Each one of these are sequential steps. You can't leapfrog ahead of one from the other. You have to complete them as you go. And that's what leads to the final duration of the construction contract. So we expect work on 3 segments to be overlapping at various times when we talk about the green, the red, and the blue. So there will be times when all 3 sections have some activity going on with all of them. In addition to the many people needed to complete the design work, we also estimate that at some point during construction, approximately 200 people will be directly employed by the tunnel program. And that's not including any local businesses and others that might indirectly support us. So the specialty nature of this work, as we mentioned before, the construction contractor's type of work to do this thing, will require both locally available labor, but will also draw in some national labor. But starting later this year, we anticipate some smaller construction projects to begin. What we're identifying here is early enabling construction work. And these are smaller projects that we need to get completed before the tunnel contractor starts their bigger work so that they're ready to support the construction that needs to go on. And we've listed them here. There's TBM power that we need to get to the launch shafts, dewatering line, which is to help provide a pathway for water to go when we infiltrate into the tunnel. And then there's a building demolition and a parking lot relocation that will be involved. Here's a site of some of the Metro West Tunnel project that we did back in the late 1990s and early 2000s. It's a launch shaft that was up at the same Mass Pike area, close to where the North Tunnel would be launching for our project. But it gives an indication of the kind of site that you need during construction. Within the limits of the construction site, the surface activities are predominantly in support of the underground work. And once mining work starts, the work at the launch shaft will typically be 24/7. So when they're doing the tunnel boring machine operation, the night shift work will typically be a maintenance type shift. So the shafts will be the only access point when they start from the launch shaft. That's the only way in and out of the tunnel. So again, it's part of the logistics of getting everything in and out all from that same spot. It's quite a feat. Everything and everyone, again, will go in and out through the launch shafts, and the excavator rock comes out that way too. We moved at the launch shaft. The material for the rock is not processed at the launching shaft, so that's loaded onto trucks and it's taken away for disposal, so the contractor doesn't do anything with the rock at that site. So we don't expect hauling to occur overnight, since the facilities will receive the excavated rock, and typically they're not open during the day or during the nighttime. And all 3 launching shafts for the program are sited inside or at the edge of the highway. So that was an important part of the preliminary design, to find shaft sites for launching shafts that are close to the highway. So when a lot of the material has to come in and out, it's able to get trucks located right on the road. So here's a shaft, just talk about launching and receiving shafts and how those are constructed. So the launching and receiving shafts will be constructed in rock using controlled blasting. So we expect these lifts, the shafts to be constructed. They'll be about 25 to 40 foot deep. The controlled blasting is done in short lifts, about 5 to 10 feet, where the rock is excavated and removed. And then they'll do another short blast after that and continue the process down to the bottom of the shaft. And down at the bottom of the shaft, you can see a little bit of a sense of the starter tunnel that I mentioned in the animation, where the tunnel operation is ongoing. And there's quite a bit of activity down there. You don't notice at the surface how much activity is ongoing because so much of it is going on down below. So while the launching shafts are being constructed, the tunnel boring machines get fabricated. It takes about the same amount of time for a shaft to be constructed as it does for the tunnel boring machine to be fabricated, so the timing there works well. Then they'll set it up and launch the machine. We talked about those intermediate construction shafts and mentioned this raised board technology and how that's used to help mitigate the construction impacts at the surface of these facilities that are not so close to the highway. So the methodology basically goes step 1 and 2. A contractor excavates through the soil and installs some supportive excavation. And then step 3, they'll drill down to the depth of the tunnel with a pilot hole, and they essentially drill through into the tunnel. And then they attach this reamer down at the bottom of the tunnel inside. And as the reamer is pulled up and rotates, it grinds away at the rock falls down into the tunnel. And then the contractor is able to scoop that up and bring it back to the launch shaft and remove it where they're already set up to handle that kind of material. And with that, I'm going to pass it off to Kathy, who's going to run us through a few more discussions about the project.
Okay, great. Thanks, Paul. So one of the unique aspects of underground construction is responding to emergencies, which can be really challenging. For long periods, as Paul indicated, there's only one shaft, one way to get in and out to the underground work zone. And there is a large underground work zone between the shaft, the starter tunnel area, or the cavern where there's a work zone, and then the tunnel itself. That is a work zone. So proper trained, equipped, and coordination is essential should there ever be an emergency underground. Because access to the tunnel and conditions inside the tunnel change over the course of construction, this needs to be well coordinated and integrated. So we've already begun talking with the emergency responders from the 7 communities in which the program, the 15 miles of tunnel, will be built, some of whom are here today, and we're delighted to see them. And the MWRA is working with them to make sure that they have the resources they need to be able to respond to this unique environment should there ever be an emergency that occurs. So the launching and receiving shafts will also be important locations after construction to control the flow of water once the tunnels are in operation. And this is a large volume of water, so we need some pretty sizable valve chambers. These valve chambers or vaults typically extend a couple stories below grade. You'd be amazed how large they are, and allow for interconnection of some very large diameter piping and valves. It's interesting, this work, their piping and the valves are so large that the structure is built around them. You built the floor, you put the piping and the valving in, and then you put the walls and the roof on top. That's not your normal construction, but that's how this is for such large piping and valves. The connection shafts, the intermediate connection shafts, are much smaller, but they're really important because they provide that added connection and resiliency to the local water infrastructure. So although most of the new system is in the form of tunnels and shafts, we do have some near surface pipelines that need to be constructed. Each shaft site, each of the includes different amounts of surface piping, ranging from as little as 60 feet to as much as just over 500 feet. With the majority of the new piping within the shaft sites or off-road. One site down in American Legion, this is at the end of the south tunnel, we have about 3,000 feet of new pipe to install. This location is key for us because it provides a robust connection between the new tunnel system and the existing Dorchester tunnel. And although there's a fair amount of new piping there, only a small portion, about 16%, is actually in roads. Most of it is off-road or within the limits of the shaft site. Because so much of this new piping, what there is of it, is not in community roads. That means the impacts on local traffic due to this program will be minimized as much as they can. And the need for any lane restrictions or detours or what have you are minimized. And wherever we need to do those, we'll work with the local communities to figure out how to do that with the least impact on the public. So what does this look like when it's all said and done? So the finished infrastructure at most of these sites is just going to be a top of shaft structure and valve chambers, and all below grade. At the intermediate connection shaft sites, again, the permanent infrastructure is smaller, but it is important. What you'll see is basically a concrete slab that sticks up about 2 feet above grade and some area for parking. At the Highland Ave interchange, we have 2 shafts that are being built, but only one of them will become part of the permanent infrastructure. The other will be backfilled and the site restored. It will be just used for construction. And of course, all the sites, as Paul mentioned, will be landscaped, fenced, and secured. This is water supply. Post-construction, when the project is all done, our operations staff will incorporate these new facilities into our water system and will manage and maintain the facilities. So throughout this design and the environmental review process, we've been meeting with communities and key stakeholders through a variety of methods to provide input on the program and also to get feedback. As Paul mentioned, there's an iterative process with the preliminary design, the environmental review, adjust the preliminary design, do the environmental impact, and go back and forth, and that led us to where we are. We've held at least 150 meetings with different folks, communities, state agencies, stakeholders, or what have you. And since 2021, we've had a working group, tunnel program working group established with representatives from each of the communities in which the program will be to provide input on us, and they've really helped us understand and refine this program. So 60% of the residents in the MWRA service area live in EJ populations, and this program serves both EJ and non-EJ communities. As part of the EIR, we analyzed potential impacts on EJ communities and determined that no EJ community would be subject to disproportionate adverse impacts. We also recognize that extended outreach is critical for such an important program, and consistent with MWRA's language access plan, we're providing access to information on the program in several languages, ensuring that notifications to events like tonight are disseminated widely, and that anyone who attends, even those who might need interpretive services, have the same opportunity to learn about the program and provide input. So what's our schedule? Preliminary design is done, as Paul mentioned. Final design just began and will run for a couple of years. Power supply, which is really important, will begin later this year to bring power to the south tunnel, and the drain line construction to provide a way to get dewatering water out of the cloverleaf at Highland Ave over to the Charles River. That drain line, we hope to start that next year. We're targeting to start the south tunnel construction, which will be 10 miles in 2028, which means in 2027 we have to have everything ready to go. And then the north tunnel would stagger a year. 2029 means in 2028 everything needs to be ready to go. There's a lot of information on this program. We have a separate page set up off of MWRA.com where there's program information, program history, reports, documents, all the environmental documents, meeting agendas. This presentation will be there, and any notices for specific communities. We have specific pages on that website for each community that have notices or what have you specific to that community, so people don't need to look far for something that's relevant to them. If you have any questions, there's an email address for questions, or Carmen DiMaria, our community relations coordinator, is here, and his business cards are back on the table behind you, so you can grab one of those if you have a question. And if you haven't had a chance to look at the poster boards and talk to some of the staff about tunnel construction and what's planned, please do so. It's really fascinating. This is a once-in-a-generation project, and we are more than excited to share it with you. And so with that, I'm going to say thank you, and we'll open for questions.
Needham. Do you expect any delays in getting federal permits with the current disorganization of federal government and talk of the Environmental Protection Agency being dissolved?
You know, we don't have any indication one way or another at this point. I'm sure over the next several weeks or months, there'll be clarity that'll come out as what's going to happen on the federal side. But right now, everything's up in the air.
Jerry Rover from Needham. I'm just wondering what the impact of this project is going to be on our water and sewer bills here in Needham.
Tom, you want to do it?
Yeah. Thanks, Sean. Why don't I try to take that? My name is Tom Garrett, and I'm the Chief Financial Officer. The question is, how are we going to afford this? Comes up a lot. So let me say a couple of things. 95% of the MWRA's revenue comes from the assessments on the member communities, communities. So the first question that we deal with in finance is one number. What is the rate of increase on a combined basis, because we've got the sewer side and the water side, year over year to the communities on average? And if we can manage that, we're going to do well. So all of our decisions, all of our strategies, all of our recommendations to the executive director and the board of directors starts from that number. This year it was 2.5 on a combined basis. We can keep it in that managed parameter, we're going to do well. So having said that, we need to know from the tunnel department, and we meet with them all the time, about how much and when, how much and when. This is a project that's going to go on for a while, and those cash flows are identified. We model those cash flows by issuing tax-exempt bonds. So those tax-exempt bonds have payment and interest that is due. And we structure that repayment around existing debt service that we have and other things that happen in the budget. We've got wages and salaries and chemicals and energy. Debt service is 60% of our budget. Fred said earlier that some consider us a construction financing agency, and a little bit we are, because 60% of our revenue goes to debt service. We have modeled this out and projected out, not just 1 year or 5 years or 10 years, out to 20 years. And we see stable, manageable, modest increases to the water and sewer bills because of this project. We're in good shape going out. It's a long-term project. You know, part of the concept of paying for big capital items like this, whether it's a city or a town or it's the state or the federal government, is generational equity. So that we're not going to burden everybody now with a tunnel that's going to last and for generations. So that will be paid for over time in a way that's manageable. And we see that when we get modeled it out. I hope that answers the question.
Carol Brown from Needham. In the event that there is some sort of catastrophe and your access is difficult to repair, what kind of safeguards are in place? And what happens when you have water under pressure in a tunnel like that and it takes you a while to access it, as opposed to an aqueduct that's higher up and easily more accessible?
You want to? So is your question is what happens, say, imagine it was a pipe break?
Yeah,
Okay.
an earthquake or something
Okay.
caused a problem.
Okay. The tunnel system is designed for a 100-year lifespan, so a number of scenarios are evaluated, incorporated into the design. This is a deep rock pressurized tunnel system, and the pressure is the water pressure. It will be 200 to 500 feet below ground, and these tunnels are very stable. They maintain. They're relatively easy to maintain. There's fresh drinking water running through. This is not a sewer tunnel per se, and they stay in operation for decades. In this region, as you mentioned earthquakes or something, the seismic activity here this is not California. We don't have earthquakes that have that sheer displacement that we hear about in California, even though I know there was one off of, was it the Maine and New Hampshire coast not that long ago. Those are babies compared to what they experience out west. But underground, because the tunnel is so long and linear, it flexes as opposed to shears. So the potential for catastrophe is greatly reduced because it's underground. And because we'll have two systems, should anything happen with one of them, the other is ready to go. Whereas right now, we don't have two systems in the Metro Boston area. But once we have the two systems, even if it was a problem at the surface, like what happened in 2010, we'd be able to move the water to the other system and deliver it. And the intent is you won't know it. You won't know which tunnel this passes through, the water passes through.
As we move forward with this project, as you can see, there's a lot of time built in for various functions. And one of the key pieces of the success of the tunneling program is the close working relationship with the public safety folks. And there's jurisdictions as we go from town to town, under town to town. And there'll be negotiations in a safety plan that is agreed upon by all the public safety experts we put together and funded, and the equipment and whatever it might be. Let's not kid ourselves. Tunneling is difficult work, and it's dangerous work. And so we will invest heavily in making sure that we have all the safeguards and all the equipment and all the training that we need to go forward and deliver this project with a fine safety record. I can see a representative of the Sandhawks is here this evening. They've been watching this very closely. Do you have anything you want to add, or?
No,
You guys are right down in the hole.
You guys are doing a great job.
I hope that the two pieces of it answer the question.
And I'm guessing that other parts of the country have done systems like this.
Yes, and we have done them here with Metro West Tunnel. We did that. We did the Braintree Weymouth Tunnel. I mean, I could go on and on. We have a good history of, these type projects without safety or injuries. And that's something, when you look at how we saw the individuals getting off of the bucket and walking down in, and it's tough work, but it can be, as long as it's coordinated with all the appropriate equipment and air bottles and all that stuff, we can do it working closely with the employees who are actually down in the hole.
Jean McKnight again, Needham. In Needham, will all the work be within the right-of-way of the state highway or other land owned by the state? And I have two follow-up questions, and that is, will any private land or easements on private land need to be acquired? And then another question, if it's within the right-of-way of the state highway, will traffic flow be affected at all during the term of the project?
I'm going to try and go through that one at a time. So, will all the work be within the highway or other areas? Within Needham. By and large, yes. The interchange at Highland Ave will be the location for 2 launching shafts. We'll have which will be within the highway right away. There's a connection shaft near the St. Mary Street pump station that will be within MWRA currently owned property. And there is a permanent drain line that will be in the city street from the Highland Ave interchange over to the river, so that we have a pathway to discharge the collected water. Those 3 areas are all either the state, MWRA, or city property, not private. Where private would kick in is deep underground. The tunnel will pass under private property, and what we acquire is a deep subterranean easement under someone's property for the tunnel to pass, and that we will acquire. We will need to acquire those under each and every property we cross.
And what about the traffic flow?
Oh, the traffic flow, because the 3 launching shafts are located right either within the cloverleaf or right along the highway, the traffic will go on and off the highway. We looked at, I looked at this recently, 98% of the material that will be excavated out of the tunnel will come out from the 3 launching shaft sites, because it's so much of that volume is the tunnels themselves, which will come out, that material comes out at the launching shaft sites. All 3 launching shaft sites are basically right on the highway. The trucks don't need to go through the local community. They'll get right on the highway. And we will have designated haul routes for the trucks to follow. So we would expect all of that to get right on the highway. The work zone is within the cloverleafs, and we don't expect any lane restrictions along the highway or anything like that associated with this project.
Thank you.
Kathy, do you want to mention the increase in traffic overall for the highways?
I think it can't be overstated how beneficial it is to have these launching shaft sites basically let's call it on the highway. And because so much, the material comes out of the launching shaft sites and then gets right on the highway. And the highways, they have capacity. We evaluated the maximum amount of potentially trucking or traffic that would come out of a launching shaft site on a given day, so a maximum, and then compared it to the average that these highways have in a given day, and the increase is less than 1%. There's only so much traffic that can come out of the launching shaft site because the TBMs, they go relatively slow. So even on a good day, it's not like there's going to be adding 20% more traffic onto the highway or anything like that. Those numbers just, they don't work out.
So I think I'm Needham resident, Paul Brown. I think here there are drinking water from our own wells, I believe. I don't know if anybody knows. So does any of this water that's flowing through the tunnel actually come into our homes?
Oh, yes. What, Dave?
Yes, hi, I'm Dave Copes. I'm the Chief Operating Officer here at MWRA, and we do provide water to Needham. Needham does have their own supply of water, but they also purchase water from the MWRA as well. There is a single pipeline that supplies the pump station that pumps into your system, and this project will provide redundancy for that pump station. So at the end of the day, you will have two means of getting that MWRA water into your system.
Sure. So I don't know where our wells are located, but are they anywhere near the tunnel? And is there any concern that the tunnel operation will disturb our wells?
So as part of the environmental review process, we looked at any public or private water supply wells, any irrigation wells, or even geothermal wells that might be within I can't remember, it was 2,000 feet or 1,000 feet of the preliminary tunnel alignment. And there are no water supply wells that we're aware of that are in that zone in Needham.
It's a sealed tunnel.
And it's a
With outward pressure.
right. It's a sealed tunnel without in construction. Once it's built, it's under pressure. It's like a pipe that's under pressure, but it's deep in the ground. So it isn't going to draw water, even if it were close to a water supply well. It wouldn't draw water from the well. It might recharge it, but it's not going to draw water from the well.
Well, I thank you on behalf of all the staff for coming out this evening. I know it's a cold night, and we appreciate you coming out, and hopefully we'll provide you with a baseline of information about this project. Please feel free, there's the ability to send us questions on the internet. We have a staff here, Mr. DiMaria has his business cards down there at on the table. And if you want to take that and have that, and we'll be posting various updates as time goes on as we head towards construction. I don't know if you want to close up or?
Yeah, and if anyone has any questions or wants to take a look at the poster boards or the staff who've been near them and quiz them, feel free. We've got a little bit more time tonight, but yeah, we're excited.
Okay, thank you so much. Please.